Okay, thank you, Layne.
Good morning, and can you hear me in the back? Professor Soraj, is that okay? I usually want to check on that because, you know, you start talking and then everybody says, oh, wait a minute, we can't hear you. And also thank you, Daryl and Professor Soraj and all of you for allowing me to be here today, and also thank you, John. John is my teacher from the past. I just, before I start off, I wanted to make a comment on Daryl's, when he opened, I noticed that he had said, he had mentioned morals and money, and it seems to me there is a confusion, conflation, and reduction in those two concepts that are creating such cognitive dissonance and also having a physical effect on the world that I really think that those should be addressed, of course not here, but maybe another conference, because that combination seems to be one of the most destructive, both intellectually and in the physical space in society, particularly how things are developed. And when Daryl developed this conference related to, if you notice, he wrote engineering from genes all the way up, and how this is going to affect nature and so forth, which is part of my conversation. I also noticed that there was a very heavy effect on self-determination when it comes to money and morals and how these interact. So I would really like to hear more about that, maybe in other discussions. I wanted to mention that. The other discussion with, is it Dr. Gillian? Did I get your name? Guidon. It was interesting that there's still some focus in the area, not you, but that there's a single gene, single outcome. There's no molecular biologists today, including lawyers, that are going to say that there's a single gene, single outcome, similar to Robert Koch in the 19th century, that there's a bacterium and then you have a set of symptoms and a disease. Molecular biology doesn't work like that. It works as a symphony. So it's not surprising to find that there's not one gene that causes homosexuality, and if you do some kind of biomedical, wizardry or whatever, remove that gene, that you're going to have a normal person. Because I don't think that this is an actual normal state. I think that there's a spectrum of human expression and particular desires and so forth are all part of that. That's an ethical statement. I don't have any idea how human beings are developed, because in science today we can't even understand a nematode. So a nematode, we know all of the genetic complement, we know all of the neurons. This is Sidney Brenner's work. We still cannot determine how it's going to act. But personally, I don't have any problem with orientations or whatever. I tend to be more focused on, what they tend to call pathological states, but with human suffering and how that can be moderated. So I wanted to open with just a few comments on some very, very key points that I thought that the professors before me started with. My topic today was related, I put on here, global justice and technology and societal innovation, particularly in the Anthropocene. When Daryl developed this conference around bioethics, and I talked to Dr. Soraj about speaking, I wanted to take bioethics in a larger perspective related to ecology and society. So an eco-society. So please keep that in the background as I'm speaking. So we developed a paper, a synthesis rather than an analytical process related to specific genes or something. We went the other way and went towards an ecological society and system. And of course the Anthropocene is the grand emergence from the Holocene and a new geological age. So I put a question here, prospects for a planetary society, which I also would like to keep in the background as I move along. That they're indicating there needs to be more discussion about bioethics in societies. On Tuesday morning, interestingly enough, as I was preparing my talk, I saw an article that was posted by a friend on social media. Most energy will come from fossil fuels, even in 2040. And this was not put out just by anybody. This was journalist Irina Slav, who is an oil and gas journalist. She opens with a question, an evocative question of comparison: which is more plausible? Flying taxis, wind turbine arrays stretching miles into the ocean, and solar roofs on every house, or a scorched earth, flooded, post-apocalyptic world? This is the comparison and the juxtaposition, completely reliant on technology. It's an interesting hypothetical. It's a hypothetical deduction with plenty of empirical evidence for both of these two parts that she looks at. And it reminded me also of a debate that maybe some of you guys, I'm from the United States, so we say you guys, I hope that's okay. Did any of you see the Peter Thiel and David Graeber debate last year? Peter Thiel is a mega entrepreneur, and David Graeber is an anthropologist at the London Institute of Economics. Gerald, have you seen that debate?
No.
Okay. I recommend this. Okay, so the two people, they express a lamentation on a future that we never got, meaning a technological future. We should have had talking phones and smartphones by the 1960s. And in fact, technological sophistication by the 1960s was at a level that was fairly high that we haven't actually gotten much past, except when it comes to information and communication. So we can talk about that later. So this future that we never got is an important debate, of course, and it would be fruitful to follow up on. I want this also to be in the background of my talk because I'm going to focus on ecology and a future that we also never got. I want to give mention to my co-authors on this paper, Professor Soraj there in the back, here at Chulalongkorn University. As you know, he's the director of the Center for Ethics in Science and Technology. And my teacher, John, is in the background, although he wasn't an author on this. Leif Edvinsson at Lund University in Sweden, and Jacob Nielsen, who's at the Municipality of Copenhagen. We all work to look at a synthesis or an evaluation of cross-cultural application for, in this case, democratic development, which could bring about societal innovation, and I'll explain that particular point in a moment. So what I sketched up for you today is also inspired by two eco-philosophers, Derek Jensen and Lierre Keith, both in the United States. Let me start with a brief history and then discuss a fundamental shift that's occurring in society and what I call an emerging techno-social order, which is it's a technosphere. And notice I didn't put society and technology. I put technology first, which is a societal envelopment of technology, a rematerialization of the technical world through nanotechnology, but also the law and precautionary principle that needs to go along. And as Professor said this morning, the law is way behind on a lot of this, almost all of it. So what is our place in nature, which is an old question, and I see that someone following me is going to cover that much more in depth. And then, of course, my question today is what more is there to lament of a future that we never had? I'm using bioethics again in a broad sense related to ecological civilization. If you can imagine being on the Great Plains in the United States and sitting on one of the mesas, it's a small hill or small mountain with a flat top, and watching the bison, a single herd would take 4 days to pass by. They graze and they walk along. And if you were to sit and watch this, it would take 4 days for a single herd of bison to pass. The elephants that are so much in protection today in Southeast Asia and India, there were elephant herds that went all the way up into China. Large elephant herds, not just the one or two that you see occasionally. The skies would be so dark with birds that you couldn't even see the sun. This is how much biodiversity that was at the time. Going back even further, there were cedar forests from the Levant, so that's Anatolia and Syria, Lebanon and so forth, Israel, down to the Mesopotamia and Iraq, and from there down, it was an oak savanna that went down into the Arabian Peninsula. For animals, 2 out of every 3 breaths come from plankton, if you want to know where our breath's coming from. The Amazon is important, but those are not actually the lungs of the earth. Background oxygen that's in the atmosphere, and then the oxygen that's coming from plankton. This is really important because as the ocean acidifies, then we start to lose this type of biodiversity. So this is the future that never was, that we can intuit when we walk outside and we think that this is how it's always been. Actually, if we could think about walking outside today, that the entire square of Chulalongkorn would be full of birds, so thick that you couldn't even hardly walk or even see the sky. And that's just one herd or one group. So in the Epic of Gilgamesh, which many of you will of course know, it's a famous epic. What was happening at the time was civilization was coming about, and this also occurred in India and China. The cedar forests were cut down to build what? Cities. So the definition of civilization is civitas, or urbanization. And to have urbanization, you have to have massive extraction, of course, outside of the cities to bring in to build the cities. If you look around in Bangkok or any major city, what you're looking at are piles of sand and steel. That's all that it is. And of course, there are adhesives and so forth with cement. But these are piles of steel and sand. If you look at Dubai, you think that, well, there's plenty of sand, you can build a city with that, but actually the sand to build the kinds of, you have to have a certain kind of sand to build the cities. So that sand actually has to be brought in on ships from halfway around the world to build those cities. If we can think about the impact on the environment, and also in these countries to have air-conditioned sand on the beach, we might begin to start to think about what kind of thinking or what is in the background. Later, of course, Gilgamesh is way back. Later, Plato would speak of the forests that were being cut down in the Aegean area from Anatolia over to Magna Graecia, which is southern Italy, which had an exponential effect on deforestation. Also, mining was producing coinage. So once coinage was brought in to basically feed the militaries and to create a market system, markets are actually created by states. The mining was going on, and the mining actually from Roman mines we're still dealing with today, with cleaning up. So that's 2,500 years or so. It would take 600 old-growth forest trees to make one of those large ships by the time shipping got going later. Writing in the 3rd century, Tertullian, the father of Western theology, said, "Surely it's obviously enough if one looks at the whole world that it is becoming daily better cultivated and more fully peopled than anciently. All places are now accessible, all are well known, and all are open to commerce. Most pleasant farms have obliterated all traces of what were once dreary and dangerous wastes. Cultivated fields have subdued forest, and then he goes on. There are now cities. He's writing in 200, 300. No longer are savage islands dreaded, nor their rocky coasts feared. Everywhere are houses, and inhabitants, and settled government, and civilized life. What most frequently meets our view and occasions our complaint is our teeming population. Our numbers are burdensome on the world, which can hardly supply us from its natural elements. Our wants grow more and more keen, and our complaints more bitter in all mouths, while nature fails to in according us her usual sustenance. Now, here the translation is keen, but I don't think Tertullian was using this because he was writing in Latin at the time. But notice that the focus here is on population, which actually I don't think is the problem. I think that the problem is the actual civilizational definition and how that comes about. Skipping over the medieval time, because at that time there was a depopulation of the cities. People left the cities. So there's not much really to say because the extractive process slowed down. Similar to a large recession that happens right now. The extractive system starts to slow down. So over in China and India, it had a similar effect, but not quite as detrimental. Let me skip over to when the great capitalist empire started, which was around 1450. So the Medici money, funding, and by 1750, then we start to see the industrial civilization. What happens here is technology becomes more powerful. So in the past, you can see what civilization was done, but when you combine that with powerful technologies, then we start to see this process happen. So if you read Oliver Twist, you know what London looked like at the time. The sky was black, and so was every house and also every person that was outside. By the 19th century, the Swedish chemist Arrhenius would speak of this is going way too far, and certainly this is going to have an effect on the atmosphere. This was the first time that you actually had a scientific evaluation, which was still speculation. It still didn't have any measurements of the geophysical system, but about 100 years after that, James Hansen would report to Congress that he was certain that this was happening. So moving up to current times, by 1940s it still wasn't known, but a new geological age had emerged. And the way that the geologists point this out is because the I'm not quite to the slide. This gives the background, the philosophical background. Thanks for reminding me there. This is the philosophical background of what I'm talking about, but I'm actually telling a story, and I have a couple of pictures for you. By the 1940s, the geologists now can see that because of the radiation fallout around the world, that the sedimentation that was occurring, you can start to read the sedimentation a lot more precisely. Whereas in the past, you would have to have fossils upon fossils and sedimentation to get some kind of measurement of what age we're in. Ice cores eventually would yield what the climate was like in the past, and then the ocean floor now gives more data. But in the 1950s, there was a soil crisis. Farms in the Midwest, we call it the breadbasket. So if you can think of the United States from Illinois down and then over across Texas and up to the Dakotas, all of this we call the breadbasket, but also it was cotton farming. And cotton farming stripped the land, and so farms would lose within 24 hours all of their topsoil. So then you have to come in with a lot of chemical intensive farming practices. In the 1960s now, there started to be a social response. So Rachel Carson, as you know, published Science Spring, I think it was in '62. And then what followed almost immediately was large-scale environmental social protest. And I want to connect this together with global justice in a moment. By the 1970s, the fossil fuel scientists were reporting anthropogenic climate change. It was already known in the 1970s, and then of course in 1988, James Hansen would go to Congress and say that he's certain that the climate now is warmer than it was at any time measured in the past. This was when it began to get into the public. I can remember at the University of Virginia when I was doing medical research at the medical school, we would sit, and this was in 1994, I was very young, we would debate not whether climate change is happening, but whether there's going to be a technological fix unless society will actually adapt. Today, I want to also say that the flag of Lebanon still has a cedar tree on it. But if you go there, I'm sure you can report that how many cedar trees do you have today? Are there big forests? Not anymore, maybe small. So the scientific debate is no longer is the climate change a matter of the anthropogenic cause. Genesis means the beginning, coming from the human being, from the anthropos. But what we are debating is whether nanotechnology can capture enough density of the solar radiation coming to the Earth. So that's one point technologically. The energy density of, say, 1 gallon of oil would take a very, very large area, maybe the size of this campus, to generate the energy needed to run the campus. So it's the concentration in fossil fuels that's the key point, and we still don't have the material science to match anywhere close to that. Today, this is a solar capture. This is an actual functioning solar capture, but I put fantasy and fiction, and I want to get to that here. I hear some of you laughing. There's another aspect that's also important that we're also debating in the sciences. This is the hard sciences. How many species are actually going to be extinct by 2050? It's 30 years, with about 10,000 species per month going extinct. And now the background rate, you have to compare it to the background rate, but because there's always species going extinct in the natural world. A lot of scientists are saying, are we going to have 1/2 of all species totally gone by 2050? And also, will civilization collapse due to the tidal surge moving in on the coastal areas where there's agriculture in cities? Right now, for example, North Jakarta has had to move. It has subsidence because it's sinking, but the tidal surge will just inundate the city. The last time in the geological age that the temperatures were at the level that they're going to now, say 2 or 3 degrees, we were already under 7 to 15 meters of water. The oceans were already 7 to 15 meters higher. Right now, I think we're about 1.7 degrees Celsius, and it's going up. Just this week, they reported that we're at the highest CO2 ever recorded in the atmosphere. So it's parts per million, 417, 418 parts per million, when 350 has to be the livable part. Okay, so, well, an avalanche of grief is actually, I think, rational at this point. An avalanche of grief, and I'm quoting eco-philosopher Lierre Keith, but at the same time, it's important to try to understand the level and depth of the problems so that we can actually do something. And how are we going to do something is what I'm going to get to in a moment. Is there a clock there?
We have 5 minutes.
Okay, thank you. I'm getting to finish up now. I want to go into societal innovation. So right now, typically if you read the literature and also if you visit with people doing production, there's an idea that the entrepreneurs are supposed to be freed up so they can enter into the market and they can create new things. But what this has led to is a gross ineptitude in the private market production. I'm quoting Bill Gates, who finally said this by about 2 or 3 years ago. Long predicted, simply because it's fragmented. You have to have innovation. You have to have people talking, similar to how the ARPANET came about, and people cross-talking amongst a lot of disciplines. So you could walk over to the physics building, you could talk to them about what they're doing, and this kind of cross-fertilization, that's all been cut off in the last, say, 30 years. Okay. So we tried to, this is really difficult to come about with this kind of societal level innovation, or how we're going to do it. How is this going to happen? One way to go is the Chinese way. So you just have massive scale development with an idea for what they call eco-civilization. This is an ideology that's developed in China that's looking to be far better than what we have in the West. And they're leading the world in renewable technology. Between the years 2009 to 2011, they used more cement than the United States used in the entire 20th century. This should give you an idea of the magnitude, and they're not stopped yet. This is just China. When you take the Belt and Road Initiative that goes over to Europe, down to Africa, you take the Maritime Road that goes back to the old Islamic trade routes. This is an enormous project. So what is this going to look like? And what kind of societal innovation do we want to have? So by deduction there, you can see that what I'm talking about by societal innovation is an integrated response to the challenges that we're presented with. So what does renewable energy? I want to take a core example of what's promoted today in the media largely, and also in academia. You will see it. What does this have in store for us? So I take a presumptive position, such as with Paul Thomas there at University of Michigan. He's a philosopher. I take a presumptive position that we're going to have this technological development and nanotechnology, but I don't take a deterministic position. In the case of this type of solar capture plant, this is not going to produce very much energy compared to maybe barrels of oil that this would actually be equal to, would probably fit in this little point right here. This is more like reality. So I've juxtaposed an actual real energy plant with actual fiction plant, but I'm calling them in the reverse, that this is what reality would look like right now if we were to impose a renewable regime onto the planet. It would destroy the Earth. To implement this kind of solar capture, you have to sterilize the land. All animals are gone. Maybe even they spray, which will also kill bacteria. And this is California in 2049. Does anybody know this movie? This is Blade Runner.
Blade Runner.
Yeah, the most recent Blade Runner.
The second one.
Yeah. So not only are we dealing with rematerialization of the world, this is what I call nanotechnology. It's actually a rematerialization of the world. This thing will be in everything around us. So if we look at the materials that we have here, a lot of this is petroleum. If you can, thank you. If you can imagine this being nanotechnology and being able to control the molecules at that level, this is the kind of future that we're focused on, or that we're going to be presented with. What can be done is this societal innovation idea that I've had all along. It would be an all-inclusive land ethic that follows Aldo Leopold's work, who was a naturalist, conservative, conservationist. And for the technology, I'm going to quote John, because to give my talk today, I went back 3 years ago to the same conference, and I looked at Daryl's site, and I looked at many of your presentations, and John at that time said we need to set the groundwork for nanotechnology. We need an ethics as a performance process aspect of bringing about nanotechnology. And so he relies on Layne, a philosopher of science from the 1960s, and how this is supposed to come about. And this also goes to what you were talking about with bioethics. How we're going to bring something about is, I think, that this kind of process, performance, adjustment governance system is what's going to be necessary, where the precautionary principle is built into the system. Right now, it's more like a gung-ho kind of thing, right? So you just put it out on the market, look at the cost risk, and see what happens as you put it out. So it's not only what kind of world that we want to live in physically, but also, as you know, one of the main subjects of this conference is what kind of human being do we want to be? And if you think that genetics is something that's powerful, wait till you see what nanotechnology and atomically precise manufacturing can do. And so I'll leave you with this. If you think about a ribosome is basically a workbench like this inside the cell, and it is what is building, it's what is assembling the proteins and what's needed inside the body. Of course, proteins are running everything in the body biochemically, and also it's the structure of our bodies itself. So there's not just a rematerialization of the world around us, but the rematerialization of the body. Very, very crucial aspects of what we need to consider.
Thank you very much. So our future is clear. Would somebody else like to make any questions about our future or on how we may get there? These are nice pictures.
I took these pictures offline, so I meant to give these after the speech was done to give you an idea. This is the megapolis game. When someone was talking earlier, I think Daryl might have said it, if you want to see what the future is going to look like in the future, we look at our young people. Did somebody say that? This is what the young people are thinking about for the future. They want that. This is what they're building in their virtual worlds. On the other side is La Via Campesina, the most important activist group in the world. In my opinion, they're going to be the ones that save us, my opinion. They're the ones that are working on, protecting the genetic knowledge from the past and the land. The half-Earth idea is from E.O. Wilson, the biologist, wants to move everyone into ultra-urbanization and basically expunge the Earth of human beings. The other side is, no, we want human beings on the land to take care of.
Yes, Chuditip, do you have a question?
We have to go to lunch.
Okay. Yeah, we're going to have any questions, please? Yeah, please.
I'd like to ask about the political aspect, because a lot of these things happening to us, we have to look into the political side. Politicians, for instance, do a lot in terms of destroying the environment and policies, for example, contribute to environmental destruction, and as such, these things, the decisions that politicians make, they kind of affect our future. So from an ethical end, what sort of expectations do we have, whether positively or negatively, when we consider this political dimension of these things, especially in the third world where governance is very problematic?
Okay, so the question is, how is this going to work out politically? Because we have to have people doing legislation and creating the legislation. Well, according to Dr. Julian, the law is way behind, and politics are too. So in our paper, what we evaluated, and I saved this for the question and answer, we evaluated how the political system is being molded in Nordic region and also in Asia. And I can talk more about this later when we have a chance. And also my email is here. But just for the quick question is, as a matter of open science, which is something that we're working on here, with the open systems, open source systems, citizens are getting together and rewriting constitutions and creating this kind of molding aspect onto the government. For example, in Iceland, they didn't completely change the constitution, but they implemented serious issues like control over natural resources, the commons of natural resources, how financial systems are going to be regulated, access to health care, access to education. So that's a case of a social democracy which is quite highly, has a lot of freedom of speech and is quite highly active. And just to give a quick example from Southeast Asia, Southeast Asia and the Nordic region, of course, have two different forms of individual participation in society. So as a matter of global justice, democratic form that affects the human being is what we're talking about. The large-scale international justice is what a lot of other people are looking at. In Malaysia, which is more of an authoritarian system, which is much of what Asia is except for South Korea, actually one thing that happened was when they put in the cyber Java and the multimedia corridor, the people began to develop their own media. And there was a famous one called Malaysia Makassar. This brought social media and free speech right into the center of a system that's somewhat authoritarian. They have different kings, and then they have a council, and then at different years a king will be the prime minister. This is the particular system that they have. So to make this short, is they were able to bring in a high level of freedom of speech into an authoritarian type system. And this can be effective, I think, as we move along. I can answer more later because the professor has to speak.
Yeah.
Very much, but hopefully others will also hear the answer. It's the first time that I've heard nanotechnology being used for renewable energy. Because my problem with renewable energy is I have two. First, it's very inefficient compared to the current available energy, which is crude oil and fossil fuel. You'd be spending so much for renewable energy compared to, it's cheaper. The crude and the current available oil is cheaper than renewable energy. That's why industry still use the oil. Second is renewable energy that we have right now is not actually environment friendly. Like if you want to have a good amount of electricity using solar energy, you would have to demolish an entire place just to create the solar panels and disrupt the ecology in that area. So our goal for the solar panel is for environmental protection, yet it disrupts ecology and the environment by creating. So nanotechnology, meaning creating a technology that makes it little, is really a good idea. However, I was trying to research a while ago. I haven't found available fundings for nanotechnology, specifically for renewable energy. Most nanotechnology right now are used for pharmaceuticals and beauty. So, have you known of any example where nanotechnology is used for renewable energy? And are there efforts to fund these kinds of technologies?
Okay, sure. Certainly there's massive investment for nanotechnology related to energy. The Korean government, for example, was funding the institute where I was at in South Korea, where in the lab we were working on piezotronics, which is zinc oxide. Zinc is a metal, and then oxygen. When this is together, it forms a kind of, you can take it as a throat lozenge. All right, inside of that's a crystal, and the mechanical deformation of the crystal of the zinc oxide is what is basically piezotronics. So that deformation mechanically of that crystal produces energy. So again, this is very basic research. So we have to start at the very basic research, and by the time it gets to manufacturing, there's a lot that's been weeded out. So these are that's one example of a possibility where you have to capture more of the energy that's coming from solar radiation, which is enough I don't, John, do you know how much solar radiation in one small area would power everything that we have? It's actually not much if we could capture that energy. Yeah, but it's not very much. But if you could capture 100%, theoretical 100%, you know, now we can do anything with the renewable energy that we have. And that's why your question really is about this. This is actually what reality would look like if we were to use the capture that we have now, there wouldn't be any people there. So what many are arguing, and I argue too, is that the sustainability movement has now become a lobbying arm for global capitalism. This is the most extraordinary set of propaganda that's come about, perhaps in human history, in our history, how the particular productive and distributive system, capitalism and the market, have actually captured the sustainability movement and made it a lobbying arm for this new production. That's another issue, but I know that you guys are activists, so you might be interested in that kind of thing.
Yes, Aldrin, please. Okay, first, Aldrin. Okay, then Marlon.
Just something about nanotechnology and renewable. There are actually many researchers done. Stanford University and research. NASA is also using it already. Say, for example, Stanford experimented on nanowires and nanocones. They created a nanostructured silicon, which normally is used in solar panels. It increases absorption of energy at a minute scale. So you don't need to cut all the trees and, you know, lay bare the mountains to have big solar panels. So nanotechnology is actually being used now. Especially NASA is using it also in their spacecrafts, etc. So that it absorbs at the maximum solar energy at a very minimum size. So it has been used, and there are, as what he said, there are fundings. It's billions of dollars for nanotechnology and renewable energy. Okay,
Alden, please. Yep.
For those that don't quite know exactly what nanotechnology is, it's the level of size of which we can operate for material reality. So, for example, I'll just give an example so you can understand the size. If we had a soccer ball, I get this from John. If we had a soccer ball right now, that would be 100 nanometers compared to the Earth. That's the distance. And then if you take the soccer ball and go down to a buckyball, which is carbon, a little carbon ball that you can't see, is very tiny. These are the dimensions that we're talking about. So if you can imagine atomic manipulation at that level, then every single thing around you that's material makes this science the ultimate convergent science that we know now. Now, if we go down another 1,000, we get to, 10 to the negative 12, or Picotechnology. That's, right now, nanotechnology is science fiction, so Picotechnology is, somewhere down in science fiction, fantasy.
Okay, thank you.
Layne, I'm more interested on the problem of my question rather is population a problem vis-a-vis with this issue of sustainability?
Personally, I don't think population is a problem. It's the way that the system is distributed, and then the form of extraction by the power of our technology and how it's used. Now, in the real world, yes, population is a problem, but it doesn't have to be. Take Vandana Shiva and also my friend Shuji Hisano at Kyoto University. Shuji says that there's enough food produced every year to feed double the amount of population that we have. So food's not a problem. Our production is not a problem. Although we should go to more of a steady state population here somewhere soon. But my arguments are humanistic and ecological, so I do not argue from a position of anarcho-primitivism, which means we should stop doing technology now and let people die who need insulin and heart medications, for example, because you have to have a technological system to support people that have to, say, take insulin and heart medications. And when I say this, people get it. But a lot of folks that I encounter don't get it, that to have what we have going on right now, just the basic essential support, biological support for many people alive today, you have to have a technological system. So I don't take a technocentric view, but I don't take an anarcho-primitive view. I take a much more complex view that has to be worked out in a political, technological, social, matrix.
Utopia.
What do you call it?
Utopia.
Yeah, you can't. Utopia is. Did that answer? Do you think population's a problem?
Some theorists would say,
It's a real problem, but it doesn't have to be.
because it's connected also as some thinkers would say, it's also connected with overconsumption.
But the most consumption today is coming from people that live in rich countries. I mean, take my country, for example, the United States.
Including Philippines.
Well, take the United States. One person in the United States consumes 300 times what one of the people in the village that you're talking about. So I don't think that it's a problem of consumption, except for the people that are over-consuming.
Yeah.
And South Korea, Japan. South Korea is a very, very populated place in a small area, and everything has to be basically imported. So you have massive consumption.
In fact, in the September issue of the Bias Journal, we have a long paper on discussion of academic censorship of discussions of overpopulation in the United States at the Scripps Institute. So it's maybe an interesting paper to look at. I will circulate it to you and have some hard copies. But this was an interesting discussion because there's some scientific groups discussing, in fact, censoring this discussion of overpopulation because it has some certain religious groups reject the discussion, and others certain kind of interesting scientific ethics.
That was my 2-minute response, but yeah.
Any other comments? Anyone? Questions? I think we.
So Peter?
Thank you very much.
Yeah, thank you. My email is there, so we can carry on the conversation later this week.